So let's go to the route map outcome. So the setting, next up setting between site with single fabric. So here there is no need of EVPN route map between Fabric 4 and Fabric 1 because this is a single fabric site here in that site and here as well. So how it what would be the outcome? So here I'm interested to check what are the next stop received here on that border for a particular route. So that route here is that VM 18 here, 10.1.10.18. So you will get, when you do that command, so I can show you that live on the equipments at the same time that I'm doing the slide, you get a view on the equipment. So if I do a show BGP L2 EVPN neighbor, which is the regular leaf as a type 2, and I want to check everything that is included in that route, you will get 2 entries. So this is important to consider. You will 1 entry that is, so let's just pick that one. So that would be not 18, this one. So I'm going to do this command. Oops, put a neighbor in front. Okay. So you'll see an entry that is for L2 VNI, an entry that is for L3 VNI, which is normal because we are using both for that specific subnet. So you'll see most of the time 2 entries here, right? One that is an L2 VNI route and one that is an L3 VNI route. Next, I want to see how this route is populated and advertised outside of the fabric. So for that, I just do advertise route for the neighbor, which is 1.3, which is the primary of that border VTEP, right? And you'll see that I've got 40.1. So I can also check that. So what is sent externally? So for that, I can do a show BGP L2 EVPN neighbor. And the neighbor that I've got is 1.3. What is advertised? It's a route type 2. And I'm including that IP here. And you see that the next stop is 40.1. 40.1 being the IP of the shared IP for sourcing the VXLAN tunnel. Then, thanks to the next stop self that I've got between for the internal BGP session between that border and the route reflector, the route that I'm going to receive here, although this is 40.1, are going to be changed. And the next stop is going to be 10.3 for the route that I advertised to the route reflector. So you understand here both the equation of the external next stop self that is performed nominally into BGP and the internal next stop self command that we add in the config in action. Next is the router rewrite. So exactly the same route analysis that I do before, but this time I'm interested in checking the extended community that is attached to the route. So you will see that here, the router MAC that I received, that is used again for the L3 VNI, this is used for the routing. So how to reach and to route up to that destination. So this is, that router MAC is 08 here, which is the virtual MAC, so the router MAC defined on that VTEP 8. So it's easy to remember. VTEP 1, it's 01, VTEP 2, it's 02, VTEP 8, it's 08, and so on. VTEP 7 here, it's 07 in the drawing. So then when we see and look at this route here, you see that the router MAC is being changed from 08 with 07, so that when this guy here, the VTEP1 want to send a route for a sent packet to that destination that must be routed, he will send that with a router MAC being 07. So this is very important to get that as well for the L3 VNI. If not, it will not work. That's just as simple. The traffic will not get routed. So very important. Likely, what we see here is that in order to get that destination routed here on that guy, it must send the traffic over that orange VXLAN tunnel with a destination MAC being 0.1. So that route ultimately received on that leaf, VTEP2, will have an associated router MAC so that when the workload wants to talk to that workload with a destination being 0.1, so that this guy will perform the routing. Hope this is clear, and we are going to extend that concept to between Fabric1 and Fabric2. So again, here there is no need for EVPN route map. So what we do have just between those two fabric, we have here again the same route. We have 12.14 being sent here. So 12.14 is this guy here that is sent here. And we are going to change the next hop through the regular next hop for external BGP that is changed. And here the receive is with 10.3, which is the loopback one of the VTEP, and will send to those guys will send with the next hop IP of VTEP 5. Same aspect for router MAC. The router MAC is changed as well. And for the router MAC, I insist there is no need of CLI command. It is automatically done, perform on the hood for you. Next up, setting between site with multiple fabric where the route map is needed. So here we are going to increase a little bit the complexity. So we receive again for the same routes here. Remember 10.18. So that was for the 3. I send that with the next hop 40.1, which is that border VTEP here. Let me put the laser again. Oops, sorry. There. Which is there, and then I send that over to here, and this advertised route would be 10.3, which is the loopback here. And then I'm sending this route to those guys with 40.1. So 40.1 being that guy. And the reason for that is I want to build this VXLAN tunnel. So that here, this guy is receiving 2.8 as the next hop, because again, we want to hop to that border, and then from that border to hop directly to that Fabric 4. So this aspect here is used through the route map. So I can show you live on those equipments. So on the 8325.1, if I do a show EVPN neighbor, so I'm talking about the routes that are sent to the border that is here. So that's this guy, advertised. So type 2, 10.18. You see it's 40.1. Right. So now the router MAC, okay. So the router MAC will be preserved. Actually, we are not going to change the router MAC. And why is the router MAC preserved? Is because through those sequences, the fact that we do not, we have a set IP next hop will not change the router MAC. So the route that is received from that border VTEP to this border VTEP, the router MAC is not changed, is maintained. So this is why that what we send here as the right destination router MAC 07. Will it have the router MAC being 01? It will break the routing because VXLAN, so the next hop IP will be that guy, but the router MAC will pointing to this guy. So this is why we need to jointly have consistency between the IP next hop for the VTEP and the router MAC of that next hop. So router MAC is unchanged. And here the router MAC is changed because we want to have consistency between the next hop, which is the border VTEP of Fabric2 with the router MAC of Fabric2. So 05 here is the router MAC for that border. So this guy, that leaf here, will just route to this guy normally. Right, so now in terms of path, if I want to trace traffic from that guy to this guy, and you have the packet capture. Again, if I go to the slide here, you can double click here. And if we double click, you got Wireshark that will open if you have it installed on your laptop. And then you've got this guy is a trace route capture that I did. And this trace here. Oops, it seems I got an issue to find my mouse. Sorry, I lost my mouse, which is a Microsoft glitch. Yes. No, still not. Sorry, just trying to recover. Where? Yeah, here we go. Yes. So here, that trace is for the ping from that VM to this VM. Okay. So the trace that we have here is done on the spine. So on that spine, I've got the circuits going to Fabric1 and Fabric4 are sniffed. So I can mirror those traffic and you'll get that. So you will see from this IP 22 pinging 23 here, you'll get on the slide, you will get the this is a layer 3 routing. So you get the source VTEP, which is the border VTEP on Fabric2 and the destination VTEP of Fabric4. And you will see an important aspect is the router MAC, which is the destination MAC on the Fabric4 VTEP. So this is quite important to note. So pay attention. You have it in the slide deck. You double click on that that stuff. I can show you that live as well. Time is flying. So I'll get to that very quickly. Yes, I've got my stuff prepared. Yeah, I can just continue, and then I'm going to issue a traffic from that VM, which is VM4. I hope you can see it. Okay, and now I'm going to ping that guy. Meanwhile, I'm putting the Wireshark here so that you can see live. Yes, you got that. And now you extract that pickup and you have it in the slide. Huh? So this is exactly what I was mentioning. And what we just want to check here is the router MAC for the destination. So here the source is that border VTEP. And then you have that destination MAC, which is 07 here. Right, so I think we cover extensively the topic of rewriting next hop and the router MAC. So I hope this is clear for you now. I'm not going to cover that right now, but if you remove route map for that we defined previously, okay. So typically you can put a sequence to remove and prevent that route map to be processed by allowing everything at the first sequence for that route map. What you will get is actually next hop not being reset and the router MAC still being the same. So for layer 3 VNI, it will work. So you get double blue tunnel, right? So this is not supported, okay? So this is not something we want to support and test and qualify. So, and this is suboptimal, by the way. And it will not work for L2 VNI. So L2 VNI, so for instance, for this particular VM to this VM, right? It will not work because remember, we have split horizon for L2 traffic over the blue. So blue to blue will not work. So overall, I don't pay attention that route map if there is a mistake in the route map or anything that may prevent the route map to be processed, that stuff is not supported. However, you may see partially working, typically layer 3 VNI might work.